All right, this video is going to work you through doing the shaft support drawing, and you got the PDF of the object with the dimensions needed on it there. So let's start with a new metric template file, and I'm going to start a sketch on the top plane, the XZ plane, and let's flip it back around. And now this object is symmetrical. And it's easier to start with our base and then kind of build our way up. So I'm going to start this one, and just like in AutoCAD in Inventor, it's easier to draw circles than it is to draw arcs. Just a fact of life. So I'm going to start with my first circle, and I'm going to constrain it to the origin and draw it out. And you see it's a radius of 40. So I'm going to go ahead and put that in. Now I'm going to do 2 more circles at the end. And I'm not going to dimension these, and I'll show you why as I'm going through here. Now, I want to constrain these things along that x-axis, and I can do the horizontal constraint. I'm looking at my screen, and I'm like, what is something weird was going on there? So I can do a horizontal constraint between the 2 centers there. That's one way of doing it. The other way is I can do a coincident constraint between the center point and the x-axis. Now, if you come over here and select something to constrain to, it'll automatically do it. If you try to do it in the drawing here, you got to project geometry. Okay, so that got those. Everything is constrained, horizontally, so they're locked in place. Now I want to draw some lines, and I want to show you 2 different ways of doing this. One, I'm just going to haphazardly draw a couple of lines here, and now I want to constrain them and make them tangent. Ooh, what happened? What's going on? Oh, the size. Let me I think because it was crossing it. We can work with it. Okay, and so you can see that it made everything tangent. Now I have to come in and trim or extend. Let me get my trimming done. Those are all extends, okay. And see, by trimming and extending, it places the coincident constraints on there. Okay, so that's one way to do it. You can just draw your lines out there and then boom, put them on there. Another way is to start and draw your lines and go ahead and make them coincident at the endpoints. And then come back and apply the tangent constraints. You could try drawing and making things tangent. It seems to get a little bit tedious when you're trying to snap a tangent snap on there. All right, and you can see, because I don't have dimensions applied, it changes the sizes of these things. So let's trim out the parts of the circles that I don't need, so that I'm left with arcs. right. And now I want to do an equals constraint between these two arcs because they are the same radius. And I don't know if it kept it on both of those. Go ahead and make those equal. Now we can apply some dimensions. And this is a R22. And these are an R40. And now I need a length. And so I want to go circle to circle. So it'd be easy to just choose you can choose midpoints or you can go end to end. And this is 100. Now that, see, it did a weird thing to me there. Okay. So let's go ahead and apply a second dimension from here, from the origin out to that right-hand circle. And I want to make it this divided by 2. And that will keep things centered in there. So now let's edit this dimension to make it 100. Pull that down so I can. Okay. I've got all my dimensions in. It says I'm fully constrained. Okay. And you can see all of the constraints there. I've made things equal, left to right, top to bottom. Everything is tangent. Got the dimensions, so we're good. And so now we can extrude this to a thickness of 18. Pick both faces, extrude it up, 18. All right, so that looks pretty good. Now we want to do the cylinder. So I'm going to start a sketch. And you could do certainly you could do a primitive. Still have to constrain things. And so I want to put it on the right side view or my YZ plane. Oh, it didn't pick up. I hit the cube instead of the plane I wanted. Okay, now you can certainly sketch now, or we can slice our graphics, F7, or click that button. And so a couple of ways we can project geometry, we can do the constraint, but anyway, I want it centered on the axis. So I'm just going to draw it. And it has a diameter of 46. Oh, that took radius. Sorry. And it is 76 up from the bottom. And now I need a constraint for there. So I like doing coincidence on my circles. So I'm going to coincident that to the y-axis. Okay. Fully constrained. And so now I want to extrude this. And because it is symmetrical, let me choose my surfaces. I want to go symmetric in both directions. And it is 40. And so you can see what we've got going here. Now we'll do the vertical parts in here. Same thing, sketch on the YZ. sometimes makes it easier to slice your graphics, sometimes it doesn't. It just really depends on your situation. I'm going to slice it because we're going to project geometry. And here I need that surface projected. Okay, now we're going to do a line, and I just want to snap somewhere on this line. I don't want to get an endpoint, or I don't want a green dot. I just want somewhere on this line, a yellow dot. And on this side, I'm going to come up and get a snap for the quadrant. And I'm going to do it differently on both sides just to show you a little something that we're dealing with. So this one I'm going to make tangent on that side, on the right side. This object is going to be snapped to the quadrants, but I want to show you the difference in the way they look. And so now I'm going to, just to keep things simple, I'm going to go ahead and draw a line across there. And I'm going to connect these two endpoints with lines. Now then, I'm going to go tangent over on that side. And I need a base dimension of 67. So I'm going to go from that point to that point. Now the 2 dimensions needed is because this line is skewed at an angle. So just hold on and watch what I'm going to show you here. And I'm going to extrude this a thickness of 18, symmetric. Okay. Now, let me go to my visual style, and I'm just going to go shaded, no edges. Now this one, this edge here, we made snap to the quadrant. And you can see that there appears to be an edge right here because there is an edge, okay, where the surface planes change. Whereas on this side, there is no edge visible because this surface is tangent with the cylinder. So it's a smooth transition and there's no edge. Now, the problem being, as you can see in the PDF, when we turn on tangent edges in a drawing view, it shows the edges of all the tangents. And in doing the drawings, a lot of times it makes it more clear and easier for you to understand that if you can see those tangents. That doesn't necessarily mean that there's a physical edge there, okay, but the drawing does show that. So if you're looking at an object, whether it's an image or in the textbook or something like that, and you see a line and there's no other line shown, on tangent thingies like fillets and rounds, then you know that line is not tangent between the two faces. Whereas over on this side, under a normal view, there is not a line, so you know that those two faces are tangent. Because some of the objects that are similar to this that you're going to be drawing will have this upright tangent to the cylinder. All right, so let me go back and edit my sketch to correct that. I want to delete that constraint. And probably easier just to do a horizontal constraint. Oh, not the horizontal that I wanted, so we'll go coincident from there. Sometimes it's harder to fix things than it's easier just to redraw them. So let me try that again. it won't pick up the quadrant. Okay. Oh, I'm still in the constraint mode. All right, so now I've got the snap for the quadrant. Okay, and so you see it corrected that. Come on. Okay, now our next step is we've got holes, and this one is going to be a concentric hole, diameter 30. So I'm going to choose that face, come over and click my reference. Okay, now the next thing, we've got two down here that are also concentric, but I'm going to show you about doing work points. And so here's one way to do it. So I'm going to do a sketch on that top surface, and I want to put a point at the center points of both of those arcs. And I'm going to finish that sketch, and now I'm going to go to my hole command, and it automatically selects those unused work points. And so these are a diameter 15. Okay. So there's different ways to do things, of course, and that's one option. Sometimes if you're doing lots of holes of the same size, it's quicker just to put in the work points in a sketch. Now for fillets and rounds, it's usually best to do the rounded portions first, just the way the program calculates it. Now we still use the fillet command, and let's see I didn't. Oh yeah, radius 3. I was looking for my measurement. So let's do the rounds first. So we've got that loop, and then we have each of the sides of our vertical piece, and we'll apply that. Okay, and now we can do our fillets, our internal edges. And usually this thing, usually it will pick up a closed loop for you. When these things get more complicated, then sometimes our fillets do not work properly, and things want to crash. So there's our part. Change back to shaded with edges, and you can see what I was talking about with it showing the edge of all of the fillets. Now, when you're turning these in, at this point, I really don't care either way. When we start generating drawings, we usually do not show the tangent with the edges unless the tangent part is not showing up in our drawings. And we have some that are kind of weird like that. So there's our part. If you've got questions, shoot us an email, get with us on WebEx, come see us in the lab, and we will get you straightened out.